Hi, I'm Jinu An. Today, I'll present our CVPR 2024 paper, Compositional Video Understanding with Spatiotemporal Structure-Based Transformers. To begin with, I want to share our research problem, which is how to understand long videos composed of complex semantic structures. Well, the conventional approaches for understanding videos have been focused on short-term clips and trained to get visual representations by sample frames and feed them into the CNN or transformer-based architecture. However, the research problem we are tackling is not just about understanding videos, but about comprehending long and complex videos. Let's look at the example. The video on the left is a synthetic video composed of three objects and their movements. The first question is whether the sphere slides. The second is whether the sphere slides before the cylinder rotates. As the question gets more complex and the video gets longer, we need to clearly understand the semantic unit comprising the context in the video. Thus, our main problem is comprehending the underlying semantic structure of a given video. To address this problem, we propose a compositional video learning algorithm to learn the multi-granular semantic structures of video. We first represent the semantic structure by converting the video to a spatiotemporal symbolic graph. Then, semantic unit representation is obtained by tokenizing the graph. These semantic units are combined to represent more complex semantic actions, such as sphere slide before cylinder rotate in the video. To demonstrate our proposed method, we conducted experiments on two tasks. The first is complex action recognition. Unlike other action recognition tests, this task should predict pairs of actions and their temporal relationship within a given video, making it much more challenging. The second is the compositional generalization test, which predicts unseen labels that are comprised of combinations of two or more semantic units, where individual semantic units are seen during the training phase. Now, let me walk through the compositional video learning framework, which comes with 4 steps. Well, it starts with constructing a spatiotemporal graph with a given video. The objects, attributes, and their relationships within a single frame are represented as one graph snapshot, while a video is represented as an ordered set of these graph snapshots. Then, we tokenize the spatiotemporal graph into semantic units, which are defined as 3 token types: node, spatial edge, and temporal edge. These semantic units are formulated to input tokens of spatiotemporal graph transformers which we designed. Through this model, semantic units can be combined and represent complex semantics with the self-attention layers. Next, by grouping each object's representation in the object-oriented video encoder, the temporal movement of each object is encoded, resulting in object-level representations. Since these object-level representations contain changes in the motion of each object, we designed a disentangling model to obtain each semantic element of objects and actions. As for experimental results of the complex action recognition task, we have conducted on 2 datasets, which are Cater, the synthetic videos, and MoMA, the real-world videos. On both datasets, we show the state-of-the-art performance with a notable gap between the previous methods. Next, the compositional generalization test. Previous methods showed a huge performance drop in both the object motion combination and the action temporal relationship combination. However, our model showed a relatively small drop in performance, demonstrating its compositional understanding of video. To conclude, we suggested an object-oriented video understanding algorithm to learn the multi-granular semantic structure of long videos. Also, by testing our video understanding algorithms, we constructed a novel data split for the compositional generalization test. Finally, we demonstrated our method with state-of-the-art performance on both synthetic and real-world videos. Thank you for listening.